Welcome back, guys. This is Eddie with Grid 9 Systems. Well, today is the first day of our new episode, or our first episode is going to be Where's the Gold? And this is going to be Kickback Wednesdays, which is basically uh, we're just going to relax, discuss some things, go through whatever general. Kind of try to do that once, every Wednesday and go through things. At some point, I'm going to try to do a live. Never done a live before, so that'll be a new experience. I kind of want someone here to assist with the chatting part of it because I don't know, that might be a little difficult doing the chat and then doing any hands-on. So could be distracting. We'll have to see. But anyhow, let's get to this here. So welcome to Kickback Wednesdays. Today's episode's going to be Where's the Gold? And what I meant by that is the gold as far as the valuables, our parts. We know that there's a lot of money in parts. It costs a lot of money to buy parts. Sometimes we buy expensive parts that we use to try to fix something, and sometimes we're not successful and we got money tied up in parts. So, that's a thing. It's part of the risk of, working as a technician, but we can try to limit. So today is kind of like, where's the gold at? Let's find the gold. Well, where is it? Sourcing parts. That's what I mean about, where's the gold? And as you guys can see, I got kind of a wider view here because I got the bench kind of full, a lot of things going on, and I got stuff behind me too that we may take the potato phone over there and check some of that out. Also, let me give you a peek at the desk here, top view. Kind of following through from yesterday, we had some meters. I didn't bring everything out, and I still can probably bring out even more meters, but we're not going to do that. I just wanted to show that, these, of course, are my top picks. Now that I have acquired them, of course, and I want to use them. But before these, like I said, there's nothing wrong with these. This is an old school one. Kind of was your basic transistor, resistor, capacitor checker, and it's got, a generator on it. It's got all kinds of neat tools on these things. They're not bad to have if you're starting off. And even if you're not starting off, you just want something that kind of has a little bit of everything and you can test, things quickly. These are inexpensive and they work great. They're not bad. Little component testers. You have a different type here that probably does it's a little bit more robust, probably does a little bit more than this one does here. It had all kinds of stuff on it. And you can find out the information online about what all these things will do. There's an individual who put that information out that you can acquire, and it has schematics and everything to this particular one here. And then you have this one, which I believe this one is an offshoot of this. They refined it a little bit better. They boxed it, made a little, and I think they have a newer one now that's kind of this, but it's got boards that you can pop in and out, so they tried to change it up, make it a little bit more user-friendly, give you more tools for the same, bang buck, if you will. But so I just want to bring those out to show that these are good. If you have so much money that you have to spend, you can't afford one of these. I get it. There's nothing wrong with getting one of these to get you started. Do what you got to do. You may be surprised you'll use this thing even today. I pick it up once in a while just because it's handy. It's there, quick, boom, get it. I just want a basic, quick analysis of something to see, is this capacitor any good? Is this resistor okay? Is it open? Something quick. Sometimes you just want to double check. Can you do that with a multimeter? Yes, you can do basically a lot of things you do on here with the multimeter. The difference is that this may give you a little bit more detail than what your multimeter does, okay? Just like the difference between what a multimeter is versus what a scope is. If you want to kind of look at what is the difference between oscilloscope and a multimeter. Well, the quickest and easiest way, and it's kind of blunt, but you'll get the idea. This is a camera, and I could take a still picture in time of what that voltage is. Where a oscilloscope is a camcorder. I can record live, and I can see everything moving fluently, what's going on. You see what I'm saying? In the background. So I can see what the voltage is now and during whatever the process that I'm doing. This is a still picture, okay? So that's a quick way to kind of tell. It's crude, but it is true about what the differences are between an oscilloscope and what a multimeter would be. So with that being said, all tools are great to have because it's kind of like a backup, right? We have 2 multimeters, 3 multimeters, whatever. Why? Because sometimes we need that many when we're checking something. We got to have eyes on everything. Other times is a backup, or you just want to have a different reading to reassure that your 1 meter is okay. So you're kind of like reference it with the other one. So that's another use of why you would have a lot of multimeters. And then you have these others so you can get really specifics. But so that's just to talk about this. That's not the real reason why. The real reason why you're going to want this, because of the discussion we're having. We're looking for gold. Well, what do you mean by looking for gold? Well, let's bring in one board here. This is a board that I salvaged out of a piece of equipment. I believe it was a treadmill. And then you have, besides this, I'm going to pile this up here for a moment. Then you have more boards that you find out of television sets, okay? So here are more parts that you can acquire. Well, what's good on that, you say? Well, if you look at this closely, you'll see that we have little SMD components on here, right? We've got drivers, we have MOSFETs, we have transistors, diodes, and what I really liked about it that, I have some capacitors, and you're going to be pretty decent high voltage, more than likely. You got varistors down here, okay? But the main thing that I got it for was we always need a fuse, right? We have good, expensive fuses here, and I believe there are 3 amps. So this whole thing's laid out with these fuses all across the board here. So, free parts. There's money here. So this keeps you from having to buy parts when you maybe just want to test something, or you may just want to use it as the final repair. Either way. What else we got? More TV boards. TVs are awesome to get stuff. Why? Because they have good components. Need heat sinks, right? There you go, heat sinks. Don't have to buy them. You got heat sinks if you need a heat sink for something to make a project. You got safety capacitors, okay? You got chokes. You got fuses. You got the standoffs for the fuses if you need them. You got connectors. You got more varistors, okay? You got more all kinds of circuitry for protection for your electrical. It's all right here. Diodes. You form your bridge rectifier with the individual diodes. You're going to have you're going to have diodes. You're going to have MOSFETs. You're going to have little transformers here. You're going to have optocouplers, transistors. You're going to have regulators. So you're going to have, you kind of follow through. This is gold. This is where the gold is, because you have components not just for repair, for testing, and for learning. This is all valuable stuff. You can use this to build projects. You can use this to test. And if you blow something up, doesn't matter. You didn't pay for it. You understand? So it's free money. This is gold stuff. A lot of these things also, if you really pay attention, there are precision components in a lot of these things. You just got to look for them, but they're in here. You have certain values that are spec, and a lot of times you score pretty good. You got nice film capacitors. So that's just this one. Okay. Here's another board. Look at that bad boy. Bigger heat sink, bigger capacitors. Okay. Let me zoom this out a little more. So you follow through what I'm saying. You got all these components all over here that are all usable, and it really doesn't cost you money. It may cost you some time. Yes, you may have to get out of your car or your truck, and guess what? Run over to that thing, load it up, take it to your house, take it apart, get to the goodies. So there is some work involved in it. But, is it worth it? Absolutely, it's worth it. And you never know what you can find that you may not want to discard. It may be something that's an easy fix, and you have something you can either use, give to someone, or just practice on. So there's all kinds of applications to why you want to source your parts via used, thrown away stuff. You have family members you can ask, hey, if you're going to throw away anything electronic, save it for me. I'll take it from you. Friends, strangers, whatever. Go up and down the streets. Everybody throws things away. We're a nation of throwing things away anymore, right? Because we buy stuff. This is not repairable. It's buy, and throw it out. Or some people have that mentality. I like to salvage everything I can, so long as it's something that's useful that I can use or someone else can use. I've fixed many of things for friends and family and strangers, and giving it away. Laptops, got a lot of laptops that are old that I've loaded Linux on it, kind of gave it a second life, right? And you share it with someone, give it to somebody. Hey, I really need a laptop to do this. Here you go. So I always keep a bunch of laptops. If someone has a need of a laptop, there's something I can give away free. Is it the best thing out there? No. Is it going to be, usable? Depends what you need. If it's to surf the net, you know what I'm saying, and read all day long. You want to do some, educational stuff, depending on what you're doing, you might can use it. It just depends. The thing is, I try to restore things that are getting discarded that someone else may still be able to use. And if the end result is that it's sitting there, no one needs it, then there's parts. There's always parts. So you have that. And here's another one. Once again, now these come out of a bigger, TVs, but the point is that you can gather all kinds of awesome components from them, and you can use these things. And if you destroy something, if you're just learning, let's say, and you break something, okay, you broke something, it didn't cost you anything, and that's the main goal here. Is you can accomplish so many things. Even a seasoned technician can use these parts. That's what I do. Do I buy new parts? Yes. I can buy new parts for sure as I need it. If I don't have something already in stock, or I feel more comfortable giving the customer a brand new component, yes, of course I'll buy the new part. If it's not that big a deal, you feel comfortable with the part you have, by all means use it. Like going back to this board that we're looking at, I've got switches that I can use, LEDs, if you needed to. I got plenty of those, but somebody may not have a lot, but here you go, a bunch of LEDs. Displays, 3-digit displays. Well, man, we can use that in a lot of things. We can make projects out of that. We can, test things, play around with it. So there's a lot of things, and they're different sizes. These are 3 digits here, and these are actually two separate 2 digits a piece. So as you can see that where it's split, so you can actually tell. But just to have you see that a little closer. Look what's on the back side. We got a PZO speaker. We got some more caps. We got a crystal. We got a regulator. So there's components. We got a pin terminal header that you can use if you needed a header. We got a micro switch if we need to use one. So, dude, from microwaves to radios, TVs, VCRs, DVD players. There's a lot of equipment out there that you can get a hold of that's not going to cost you anything. You know what I'm saying? And you can share your parts, in your whatever you're doing. You can, when I say share, meaning like you can fix things, you have the parts, you can repair things, and then give those things away if you're in that type of situation. I always want to help people out if I can, so I do when I can. So because it's not always about the money. To me, it's more of, I enjoy repairing. This has become more of a hobby anymore than really work, because I enjoy doing it. I probably do more, uh, believe it or not, I probably do more help work for people than I do charge work for people. I do make some money here and there, but uh, I also do a lot of free stuff too. So just for the community, for people, for friends, family, you don't necessarily charge people all the time. I don't, because once again, I enjoy working on things. So, and it's a learning experience. You might get something you haven't worked on, so you kind of get in there and see what you can do for them. So, anywho, that's what was going on. Put your comments in. Let me know what you think about that, because, I think everybody's under that understanding. Parts are nice, to have parts. Everybody needs parts. So I'm going to clear the bench here, this little work area here, and we're going to just pull some stuff, pull some components. Let's see what we got that we can pull off of here. Yeah. Now, on these TV boards here, let me put it on the top view here. The TV boards, what I'm more interested in this right now is actually the fuses, maybe the caps. Let's pop some of these caps up and see what they are. Yeah, they have the little sticky on them. So you definitely want to try to get underneath it, so that way it'll make it a lot easier for taking it off here afterwards. And these resistors, they're also glued on. At least that one was. All right. So now most of that stuff's up. So what I had planned was to come in with a vise here, hold it up, You know what I'm saying? And just lift these up. What I was going to do was use my hot air and just pluck these off of here. I think we have plenty of room for that. And let me see. My hot air here. Trying to make some room, guys. Let's see. Yeah, we might can do that. Let's see. I got a tight area here, believe it or not. It's tight. All right. We're going to go ahead and take that off of there, because we're going to come in the bottom here and we're going to heat this up, and we're going to try to get these components right off of here real quick. Okay. Let's turn this on. And what temperature we want? We want nice and high temp. Why? Because we want to pull these off without any problems. So we're just going to kind of preheat the board here a little bit. And this is something you guys can do at the house, you know, just heat this up on the bottom, get it warm, and most of these components will pretty much fly off of here. Should. Now this board's interesting. It's not a through hole. Everything is placed on the top, okay? So we're going to see if anything here just kind of like falls. Still on there pretty good. You guys, I don't think you can hear the air. I'm just preheating the board here, because I'm trying to find out if it's going to release from the bottom here. If not, at least it'll be warmed, and we can then hit the top, and it should come off fairly easy once we got the bottom. The other thing I could do, which with this I could have done, is I got a flatbed over there, a heat plate, if you will, and I can lay it on there and just warm it up gradually, and probably go over there and just pull off everything right off the board without having to do this right here. But I figured I'd do this here now for you guys so you could see. But it looks like it's really, really, really not wanting to work out that way. It's absorbing my heat. So let's do a little bit of top. I didn't want to hit it on the top directly because, you know, with fuses, you don't want to blow the fuses, you know. Too much heat will blow your fuse. And it will bust the cap as well. But see, we're starting to get components to come up here. Guys, it takes a little bit of effort, a little bit of work, but the end result is you're going to have a lot of parts. And I don't necessarily always pull all the parts. I'm doing this to show, but I like to keep it on here. That way you don't lose your parts, you know what I'm saying, or misplace them. You just grab it, you know it's there. You take out what you need and you're done. That's usually how that would work. So yeah, this is getting really hot. So they just laid those there. Those would be better off taking them off with your soldering iron than heat, because you don't want to heat these up if you want to reuse them. Like as you can see right there, you know, this one's still intact, but you could stand the chance of hurting it. So probably better with just getting you know, just getting your trying to see if I can get this back here without making a big mess here. All right, let's do soldering iron. Let's do the soldering iron. So we got some fuses. How many fuses did we pull out of here? 2, 3, 4. And if you don't think there's gold here, price those 3-amp fuses like that, the style, and see how much them things don't run if you don't think they're expensive. All right, so this cap, what was this cap? This is trying to clean it off here so I can see what this is. You know, these are, it's like 35 volt, 270 microfarads. Yeah. Actually thought that would have been a higher voltage, but they're not. So that's even better yet, because these are more actually usable. Lower voltage 35. It's more of an average, so those could be used. And you see it's 270, so it's a little bit different. So what's the reason why we want these tools? Well, we want these tools so we can check on our components after we source them, right? We want to see if they're any good. So we're going to have to do testing. Let me bring that up, guys, so you can see 261. And I don't know about you, but I ain't seeing it, man. Whew. See if I can adjust that. There we go. 261.6 microfarads. And our ESR is 0.05. So not too shabby for a capacitor. And you got the double beep. So, you know, you guys who have one of these, or even if you don't, the reason for the beeps are so you can have a, you know, kind of like a quick indication. It has a table that it uses for what a capacitor is good or not. Okay, according to the test it does and the ESR that comes up. So it will double beep when it's a passing. You know, if it's good, beep beep. If you get a single beep, it could be just that it's could be good, but kind of iffy. And then there's like a beep as well, which basically, you know, tells you not good. So it does have that. And believe it or not, I know guys are going to be saying, oh, that's not the best thing out there to check capacitors. You're right. It's not the best thing out there. There's better equipment, but it also costs more money and everybody can't afford it. And that's why I'm so big on this, that even though this may be expensive to someone coming in that says, oh, wow, they want, $80 or $100 for something like this. You have to realize what other equipment is valued at to try to buy. It could be into the hundreds or $1,000 to buy something more robust. But the thing that I wanted to say is for what this is and how it works, it does a very fabulous job. It really does. You can compare this to one of your more robust capacitor checkers that actually has a means to check, the dielectric and actually put voltage in it and do all the fancy stuff that you can do with a capacitor. And you'll see that this thing can go heads up with it and doesn't have any problems. It's I've went through a lot of capacitors with this, and I've compared it with other better equipment. And this is why, after you use this for a while, you get to know your equipment, you know what you could consider. Yeah, I'm not too sure about that one, and know and be confident on one that is. And it goes by, the experience of using both pieces of equipment, but this does the job. It does the job. But like I also said in the previous video, it does have limitations. After you get below a certain microfarad, then, it becomes a little iffy. Like, I'll trust this somewhere in the neighborhood of 5 or 6 microfarads and higher, not below that. Below that, then I'm going to go with something different. And also, I think after a certain amount on the high side of capacitance, maybe 15,000, I think it was somewhere around there, then also I'm going to go rely on something else. So there's an area, which I think it's a good area anyways, that if you are checking something between 5 microfarads and all the way up to 15,000 microfarads, you're going to be okay with this. It's going to do a decent job. So anyways, that's what I want to say about this. You need this to test things. There's other means, guys. There's other ways of testing. Let me show you something else here. Hold on. Let me get another piece of equipment. Obviously, we know that we can check that very same capacitor with your standard multimeter, okay? But especially with this particular one here, let's see here. All right. So now with this one, you don't have to worry about polarity. It figures it out. With a multimeter, you have to pay attention to polarity. You have on a capacitor, your indication varies, but usually it's a stripe. Okay, that's your ground. Okay, on most of your electrolyte capacitors, you have a stripe. Okay, so that'll be your ground, and the other side's your positive. And it'll show that minus sign. It'll have a white stripe or something like that. Check your capacitors. There's all kinds of variants, and sometimes they're not what you think. So you need to know what side's positive or negative when you use a regular multimeter. So if we check this one real quick. It may not read it. So just letting you guys know, it may not read it. It's very slow. There it goes, 275.6. So if you had that, you read this, it's a 270. We're showing 275. That's within a ballpark. That's good. But this won't tell you anything else. That's all you got out of it. Okay? So this is why for a quick go, no go, that works all day long. If you really want to find out the condition and the health, you're going to need something like this. Okay, but if you don't have this, and let's say you have just the multimeter, but you have one of these, you can turn this on, and you can actually, and this is Kelvin too, so makes it nice. You can put your test lead on there, and this will show you, or should show you, resistance. 0.8 volts. And it's showing 33, 34 mega ohm. That can't be right. Just make sure I'm getting a good connection. Now I'm getting 1 volt. It's climbing up, guys. Well, let's do this on our meter here and see. I'm going to put the meter on resistance here, the one on the screen, guys. And let's take a reading here and see what we get. I know it's easy to probe the one on the board, but I don't want to get a false reading. Try to get as much accurate as possible. So see, this is showing 11. See that? 11 mega ohms. And this was showing 33, which, let me see. It's in spec. Just checking this out, making sure it's right. So don't know why that's showing so far off. Let me check this again. Make sure I got a good connection. Yeah, 260. And we're showing 0.02 on ESR. So, and the ESR is, guys, it's equivalent series resistance. So for those wanting to know what that means. So let's do this. This didn't work out the way I thought it would. Trying to do a little cheat sheet, but it didn't work out. So let's try. Let's try not to drop something and break it. All right. So let's bring in something else. Let's bring in this one here to try to check the capacitor. Okay. This is a little bit more robust meter for testing resistors, capacitors, all that good stuff. So do you see 244 microfarads and 0.06 matches what we were getting on the peak for ESR, and we're still within spec. Now, I like to usually bring it down where I can specifically go to what I want. Where's my ESR? Oh, there we go. And this has everything as well on it. So if you want to know more about what's going on, you guys can see. Let me zoom it down a little bit more. So you guys can see we got a little bit more finer detail. And then you can, on this, you can change frequency. So we're at 1 kilohertz, we can do 10. Doesn't work under 10 kilohertz. Oh, am I touching? No. We can go to 100 kilohertz. Nothing's coming in. We can go to 100 hertz, and we have a reading, 255.1 and 0.1 ohm. 120 megahertz or hertz, 120 hertz, and then should go back to 1 kilohertz, which is usually the standard on the caps. Now, if you want to be specific on that, you can pull up data sheets for that component, and it will tell you what those specs are. Like, it'll tell you what to test their brand or their type of capacitor under what hertz. So you can do that as well. Typically, everybody just defaults to the 1 hertz to check the capacitors, or 120 is usually what you do. So unless they're specific about it, that's kind of the standard. 1 hertz. That's for that. Let's try this on board and see how it works. Let's try it on board. Get the right thing going here. I'm going to try to get a good connection because I've got a little bit of junk there that might be hindering it. We'll see what it does. So you see, I was trying to get a connection. Hold on, this might be a little bit more. Let me clean this area here. Just trying to get a better connection. And we're just trying to prove points here about how good one is versus the other, and capacity and all that. So that's on board. So we're basically getting almost the same reading that it was off board. So that's a good thing. This is where you can test something. Now, that doesn't mean it'll work all the time. And this is what I was talking about yesterday. It depends on the circuit, what's attached to it. We're going to use the peak. Peak is still showing good, 255 microfarads and 0.05 ESR. So you see, we're not that far off from either one. Okay, we have a pass on both. So I'm just trying to say is, for what this is and what it costs, it does what it does. It does the job. And it's very simple. You don't have to think about it. You have 2 buttons on here, an off and an on. That's it. And so it's a no-brainer to use this, especially for those who are either new getting in, or, you know, if you're like me, I ain't got time to be messing with that, and you got to figure it out. You know, a lot of times we just want to get the information and get out. This has got, it's robust. It's got a lot of things. We can do your difference. It's got the delta. It's got the the what is that? I can't pronounce it now. The Q rating. It's got the what is it? I can't get my words. And then we also have our what do you call it? A dialectic. So it has the availability to do that. And so much more. You can get relative percentage on here. It's got a lot of things going on with this. It's even got a backlight. So, but we don't use it all the time. We don't use it all the time because for that very reason, we want it for specialty reasons. When we have doubt, when we need to be precise. So this will do what you need to do all day long for your average repairs. You don't need anything else. So it's a good tool for that. So that was the caps. Let's get this out of the way. I don't really want to make this too long, although this is Kickback Wednesday, so we have plenty of time. I'm not in no rush. Some of you may not like it, but this is going to be probably a little bit long video, just because it is what it is. All right, so here we have another board. And the reason I'm going to pick this one is because let me fire up my desoldering gun. So we have that. Let me get back in the picture here for you guys. Don't feel left out, left alone. Don't mind the wires. I got wires everywhere. As you can see, there's wires hanging everywhere around here. So, well, let's do something real quick. I didn't want to put that away. I wanted to show you the I want to show you real quick that we can take apart, you know, using the soldering iron. We can just take this off probably just as quick because they're just soldered on the top. So we can probably just lift the leg up real quick. That easy. It's not going to take that long. Okay. Ow. Stupid board was slipping and wound up burning myself. All right, there's another one. Yes, it's hot. So you could do that a lot quicker. And a lot of the SMD, if you're getting a capacitor, you can try to like work one side and then the other side, and then the other side, and then the other side, and you could try to waffle it back and forth, and eventually you would get it. Put more solder on it, some flux, it'll come off. But you know, if you got tweezers, you can use tweezers. We have you guys are familiar with these little handheld. These are pretty good. You can get in here and get all your little things. So there's another tool that you don't use that often. Do you have to have it? No. Does it make it easier? Yes. Those are the difference. So when it comes down to repair, everything is really at the end of the day, some of it's convenience or just what you like. You don't necessarily have to have it. Just, you know, how easy do you want something to happen, I guess. All right. So back to this thing, waiting on my desoldering gun to get warmed up. So we got more caps, guys. We got caps. We got these fuses. Let's check the fuses out. See how they turned out. See if they're any good. Where's my probes? See how they turned out. And if you're looking at the screen there, multimeter 0.1, that's good. 0.1, that's good. 0.1, that's good. And 0.1, that's good. And the reason it's not beeping or anything, that's because that's just resistance check. So, all right, there's our gun. Good, good, good. Let's clean this out. Every now and again, I like to shove a rod in there, make sure it's clean. And let's take some things out. Let's start with this cap right here. So it's as easy as that, guys. See? We got a cap. This is a, what is this? Well, you know what? We have a tester here. So if it doesn't have some identifiable markings, we'll just test it. And it's saying, now see here, this is a prime example. We just tested this capacitor. It came out with open circuit or low capacitance, okay? You only get a, which means it's not sure one way or another if it's good or not, but it's giving you a warning that it could either be an open circuit, okay, or a capacitance. Now, which is cool. I wanted that to happen, so that worked out good. To prove to you what I was saying is correct. So this is a low capacitance, more than likely. Let me see. Oh yeah, here we go. 0.1 microfarad. Okay, 0.1 microfarad. So this is what, 1,000 pico? Yeah, it's 1,000 picofarad, or 0.1 microfarad. It's low. It's on the low side. Now, not too many multimeters will read that either. But let's do a comparison here to show you, even though, guys, this is a very inexpensive multimeter, one thing it does good, it can read very low millivolts, and it can read capacitors really well too. And it's got a pretty high resolution, so let's get into the capacitance test, and let's test that out and see if it'll read it. So it's saying 87.17, okay? So it's reading just under that one, that 100 nanofarad, okay? So it's reading it, and that's my point, that this wouldn't read it, and this isn't the greatest meter, but it does a good job of showing you a go, no-go scenario, because it reads. Let's bring this one here. I'm just trying to show you that just because you pay a lot of money doesn't mean you're going to always get everything you want. So even on this fluke, let's go to the capacitance test here, and let's see if it'll read that. Okay, it's reading just like my other meter just did, right? 86 nanofarad. So I would say this is spot on. For a cheap multimeter, this thing is giving me the same reading the fluke is. Okay, so let's do one up again. Let's bring this back into the picture. I'm not convinced that this thing is working right, or maybe I'm not using it right. You would think if this thing reads resistance, it would have given me some sort of reading. It's showing 120 something. I'm just looking for the ESR on that, but it's not working out the way I wanted it to. Where's my other tool? Let's bring this over here. Now we couldn't get ESR, so this will prove the point as well. So this one, because it was low, the reading, the capacitance on its low, the peak couldn't do it. Your regular multimeters that I use here in that flute could read it, and it's showing about 86 nanofarads. Now we'll use the better one here. Let's go ahead and go to capacitance. There we go, with ESR, and let's see what it shows. So if we look at this, showing 87, we're showing 86 on those and change, right? So this one settled right at almost dead even 87, 0.1. So yeah, almost 87. ESR 117.4. We were getting under the resistance test with this meter, okay? Turn this back on. We were getting this showing 117 ESR. Let's see. Whoops. Let's see what this says again, because I think it was saying 100 and yeah, it's showing 125, 126, 125, 126. It's bouncing. So I'm just using this to read the resistance. Okay. So if I didn't have an ESR meter, is what I was trying to do with that. I was trying to get some sort of reading for the ESR. May not work exactly that well, but I was trying to see if there was a way around to try to use that if you didn't have the means. So that's pretty high ESR for a capacitor, but it's really not, because it's made to be that way. So according to this, if you look at it, it shows 0.1 microfarads with 120 ohm. So it's falling right within its specifications. So if you look at that, you can see right there. See the ohm symbol there? So spot on. So you see why now, if you needed to use, if this is all you had and you got to a point where it wouldn't read it, knowing your tool, well, the reason it's not reading it is because it's too low. So you kind of validate saying this just isn't necessarily bad just because this couldn't read it. Okay, so once again, knowing your equipment. But you could take a regular multimeter and you're able to get a reading out of it, okay? And I showed that with two different multimeters, but we still needed to see what our ESR was, and we had to go to a better piece of gear in order to do that. And then we were able to find out that, yes, this is still within specs. There's nothing wrong with it. So I'm just trying to show the differences in the tools and why you would need more than one multimeter, why you would need more than one capacitor tester. You know what I'm saying? So, and that goes throughout. We usually have more than one soldering iron. If anything, only to have a backup too. Sometimes because we need different tips and we don't want to You might have a soldering iron that's kind of difficult to change tips, or you have a tip that's really big for, you know, heavy duty ground planes, and then you got your other one that you kind of do a general service with. I have 4 different soldering irons up here. You know, I got itty bitty, medium, and big. You know, I got the little tiny, the little tiny one right here for the little small stuff. You know what I'm saying? Um, I got the one I used before, which you guys see. This kind of like the general go-to, the everyday thing. And then I got the Big Daddy, and that is for those big ground planes. Get in there and melt the crap out of it. That's what that's about. And then I got a fluke. If I need fluke, I got not fluke. What am I talking about? Heiko, man. I got the Heiko if I need it. But it's right there. So and I got other ones back there. I do have other different sizes if I need them. I got different sizes and spares just in case, because you always need these. That's maintenance stuff. So there's all kinds of reasons. This thing's still getting hot here. Did it go off? Let me pull out some more stuff. We got a relay here. We like relays. Let's get that relay off of there. Oh yeah, that's got a nice ground plane on it. All right. Look, guys, we got a relay. That cool? We have a relay. Now, you have relays. How do you check these? Well, you have different ways you can check relays. And we'll go through some other components because this is Kickback Wednesdays. And we're just going through different things, talking about different subject matters when it comes down to equipment, how to go about testing it, and how to check different components. Because that's what we're about. We're about learning, right? So now if we want to test, you want to test one of these, well, the simplest way to do that is to get your continuity tester. Okay, get your continuity tester. You put it on your legs. Now, on here, if we look at this, it's a 24 volt DC. So that's the voltage it's going to use to operate under. Okay. Then you have, a lot of times you have, it tells you everything anyways, what it'll do, you know, your voltage, your amperage, and all that good stuff. A lot of times it'll show you on here, like here, there's a line here. Sometimes you have a line, sometimes you have an actual painting or drawing. So you see that little, I don't know if you guys can see it, but there's, you know, like there's like a crease here or a mark. So that's your coil side, or should be your coil side. So that means that's where you're going to put your positive and negative. Okay. And that'll make the relay click. Let me turn this on. Let's put 24 volts on here. It'll probably run with less, but we'll do the 24 volts. Okay. And let's make sure we should hear a click. Well, it's not. Did it make a liar out of me? Well, you see what I did, right, guys? Sorry, somebody, my wife was calling me. You saw what I did. I got the multimeter and was trying to run the relay. This doesn't output power. but a power supply does. My bad. Okay. So anyways, we'll put this on here. We should get a click. I don't know if you can hear it. Okay. So now we can put our continuity meter on here. And our continuity meter, if you look at it, it says open, right? But when I click the other side, watch, we have continuity, 0.0. Okay, so we can test and we know that it's working. There it is, making contact, and there it is off. So that's your quick way of testing your relays, if you have relays. And you can also take a measurement, but you can see you're not going to read that because it's open. Now, what you can measure, if you didn't have any identifying marks, you can measure with your own meter, and wherever you get the resistance, which you'll see here, that's going to be your coil right there. That's how you identify your coil. So if you don't have a mark or you're not sure, find those two leads, put it on there, okay? Put it on there, and then you have your resistance, which you see right there, okay? That's your coil, so you know your power goes on that side. And then this side, which if you're probing something and all you get is open, as you see right there, it's open. That means that's the side that turns on and off when you energize it. So just basic stuff for those who don't know. Now you do. What else we got that we can pull off of this thing? You know what? I may have to pause for a moment just to get that call. Hold on, guys. All right. Sorry about that, guys. I do take a call. Life happens. All right. What else we got here that we want to check out? Diodes. We can pull a diode out. Now that you gotta have a diode, but we'll just pull one out. Why not? Where is my? You ever just misplace all your stuff and you can't find it? That's kind of the norm. All right, let's do this one right here. All right. These are one of the best tools you can have for taking apart your components. Let's go ahead and just take a few things out. One good thing about, I'll take this out, but I'll show you anyways too. These optocouplers. You got an optocoupler. We're going to take a crystal out. We got a crystal. What else can we take out? Let's take out this beefy looking sorry guys, beefy looking inductor. We got that because we're going to test these components. Okay, we're going to test them out. Let's take out this here too if we can. This transistor here, whatever it may be. Woo. They do get hot, so be careful. Things get hot. Things definitely tend to get hot. We got a bigger device here. Let's take this one out as well. If there's extra noise, it's because I turned on my fan to pull the smoke and odor out and stuff like that. So, all right, let's get this little, this will be a good demonstration for these. Let's see here. Actually, we got two of them right here. Ooh, that's hot. Ooh, very hot. Very hot. Very hot. Let's see. I wanted to find a specific component right here. This will do it right there. Maybe. If I can find it. All right, we got one leg up. See if we can get the other one. All right. We got a couple of components. Let's get one more thing out here. All right. Try to see what else I can pull out to check, but let's see how difficult this is. And doing this too, guys, will give you practice on pulling these things out and learning, you know, how much heat you can really withstand on something. All right, so let me put my gun up and turn it off because I think I'm done pulling parts for right now. And let me get my big hefty duty soldering. So when you're doing heat sinks that are attached, it makes it a lot easier coming off because you got the heat. Oops. You can really get that heat put in there and have no problems whatsoever pulling this out. There you go. If you use a small iron, they're going to be there forever. If you use heat, you're going to heat up a lot of the board and damage it with the hot air. So be mindful of that. Pick the proper tools to do the things. Hot air can really damage your boards, warp them. It'll lift up the pads. It could do all that. Same thing with the iron. Will do that too, but it's too hot. So you got to be careful using your tools. I think we got enough components, because what I want to do is bring in our different tools once again to test and see the differences in our readings and what we get. All right. So let me lay these things out here. Okay. So we have an inductor. We have some sort of transistor, diode, something here. We haven't figured it out yet because we didn't test anything. And we got another same unknown component there. We have our optocoupler, which we know, a diode. We have another diode, or it may not be a diode, right? That could be a Zener diode. We have a capacitor. And do you guys know what these are? Be careful. Be careful with these, because they can get you in trouble. Let's get the microscope in here. All right, let's get this in here so we can see what's going on. Do a little adjusting. So you have a reading here that shows a 103Z, 1 kilovolt. And then you have another one here. Zoom that in a little bit. See if we can read it any better. I don't want to get my big finger in the way. This one's a little harder to see because of the glare. Let me adjust the glare thing here. Here you go, guys. So that's a CY 102, 440, 250. So we see these nice little colored, at first glance, for new beginners, they look like capacitors, every one of them, but they're not. Okay. So be aware, read those things, and make sure what you have. Okay. And for testing purposes, use the least damaging equipment to test an unknown component if you don't know what it is. You know what I'm saying? Let's test this capacitor just to see on this Peak Atlas and see if it will figure out what a capacitor is, right? Let's see what it does, because we want to know, right? We want to know. All right, let's hit test. It's saying no component. So I did that for a reason. This isn't a capacitor tester, but it is a component tester for semiconductors, I guess, if you want to call it that. It'll check the diode. There you go. Diode junction, red and green. It tells you the VF, milliamps, and that's pretty much it, the basic stuff. Okay, so we know that's a diode. Now the other one that also looks like a diode, get that on here. Let's test that, which would be this one right here. Let's bring that one under the microscope real quick. Take that out of the way so you guys can see it better. So you see a little glass. That can be, you know, at first glance, it could be a regular diode. Oh, you guys ain't seeing. Sorry. Looks like a regular diode. So let's check it on here and see what we get. It says diode junction. Okay. Now, is it a regular diode or is it a Zener? This only came up saying that it's a regular diode. Okay. So to me, it looks like it would be having challenges to tell whether it's a Zener diode from a regular diode, because you have both availability to check the forward and bias on it, right? So now let's check it on an actual Zener diode tester and see what we get. So according to this, it's showing 22.45 volts, 22 volts. Now, are my leads on right? Well, we flip this around in the opposite way. Now we're reading a regular diode, which is what the other one was doing. You see that? For Zener, it's flipped. So normally you put in your black to black, okay, red to your anode side, black to cathode side. With a Zener diode, it's actually backwards, okay? Because remember, it's a Zener. So we're doing the opposite of a regular diode. So now when you test it this way, we show this is a 22 volt Zener diode. Now, turn that off. We have the ability on here to also check for Zener diodes. So if we put this in here on the bottom scale, okay, oh, you guys, sorry. Okay, we're gonna check it on here now, because this has the availability to do diode checks. My wire came off. I think my contacts are getting wore out. Yeah, that's not biting as good as it used to. All right. Let's go ahead and clamp this side. Let me turn it on. Here it is. Zener diode. And this one tells you Zener diode 22 volts, right? It's on there. You guys can see it okay. All right. So as you can tell, same as the peak, it told us it was 22 volts. Even with the cheaper version, it has a function for Zener diode, showed me the same exact thing. It works. Now, that's just to prove that you don't have to spend the big money. You can spend a little bit of money and still get accuracy with your capacitors, with your other components. And that's what that's what we're doing. We're just showing the differences, okay? Let me pop that open. Let's do a capacitor real quick. Capacitor says it's 10.07 nanofarads. Okay. Now we can check it with our peak. And remember, this thing had a limitation on, okay, I was touching the leads together just to make sure that it's working. So now when I touch this, it's not even coming up. See? Open circuit, low capacitance. So the peak, okay, at this point would not read, okay, this capacitor. But if we put it on a cheaper tester, it does it all day long. So you see why this is still handy, why I still have it. You have to know your tool. It doesn't mean that this is a bad tool. This works excellent for what the range that it works in does. Okay. This will not work in the higher microfarads as good. Doesn't do that good a job, but it works fantastic for lower values. That's my tip to you. Lower values, general values, I guess, if you want to look at it that way. Now, this is where I say on here, cautious on these. Sometimes they're not capacitors, okay? And I think you know where I'm going with this. This is not capacitors. This is a varistor. Now, we'll throw that in there. We'll see what this comes up with it. And this says, what does it say here? It says capacitor. All right. And gives us a reading. Okay. No ESR. Just now, let's check this one. It says this one's a capacitor. Picofarad. May very well be. Maybe I was wrong. And it's not a varistor. This won't read it. I think we already established that below a certain degree, it doesn't read. I want to say it's below 10 nanofarad or thereabout, somewhere around there. I'd have to get the manual out to see where it gives out, but so not getting what I want to see. Let's get the multimeter, because I'm going through different things. In fact, let's just use this one, because I know this one will read as well low values. See what we get here. 8.2 nanofarads immediately. 0.883 nanofarads. Okay. Now, go back to this again. Why I'm doing this is because we're going to go through a practice run here. I want to find out what this is. So when in doubt, get online, go to your Google or whatever you use and put in a search for that. Okay? 103Z. 1 kV. Let's do a search just to see what comes up. What happened over here? Okay. So according to Google, and I'll let you guys see, I'm just trying to prove a point here, guys. And I'm sorry, I thought I had the microscope for you guys. Let me show you that. In case you're following, you're looking at those numbers, okay? I'm checking this one out right here, the light blue one, okay? So look at the light blue. According to Google, it says what? A 103Z 1 kV is a high voltage ceramic disc capacitor. Its code means it has a capacitance of 10,000 picofarads or 0.01 microfarads. Okay. So we broke that down. We verified it is a capacitor. Okay. That is a capacitor. How about the next one? You going to do that next one? Just a practice run. This is a CY 102 M 440 slash 250. All right, so now this one says, this is the dark blue one. This one says, this query references two separate electronic components, a CY safety capacitor and a 440, 250 standoff. Okay, so basically, the CY 250 standoff, it's a safety rated ceramic disc capacitor with a capacitance of 1000 pico, also written in 1 nanofarads, and a standard voltage rating typically of 400 back or 250 volts, okay, AC, depending on the safety class. The M donates a capacitance tolerance of plus or minus 20%. It is primarily used in power supplies, filters to suppress electrical noise and protect users from electrical shock. Okay. So once again, it's a capacitor, but it's a specific capacitor, okay? Very easily can get confusing with these caps because of the colors and also whether or not they may be a varistor or not. So you need to check those. If you happen to check one with your test tools and you see that you're not getting a reading, that could very well indicate that it's not a capacitor. It's supposed to be open, and you probably have a varistor. Okay. Either way, do the testing, right? Test it. Follow through by looking up the parts if you can, because you don't know, a varistor can be shorted too, and you can get a reading on it. So that's why you want to check, just verify what they are. And I don't know, do I need to bring out a varistor so you guys can see? I think there was one on there somewhere, maybe. I don't know. I'm just going to get one so I can show you. I just want to show you, just to be cautious when you're working with this stuff. These aren't capacitors here, okay? These are not capacitors, and I'll show you that by using the multimeter, okay? And we'll take a reading on either one of these. This one's showing a, oops. This one's showing a, well, you need to stop. All right, under capacitor, this one's showing a 0.5 NF, okay? This one's showing 0.3, okay? Now, that's under capacitor. If you do a, if you're just doing a standard continuity and you're checking, you'll see that you're not going to get anything, right? It's just open. And I believe with these, you get the same result. See? Same result. They're open. But you know, we just checked and it said it was a capacitor, but they're safety capacitors. Some people might call them that. I call these varistors. If you look these up, they'll come up as varistors, and you have to check them a certain way too. That's for bells and giggles here. Let's just try that real quick on here. It should come up with something. All right, it says capacitor, and it gives you a reading. Okay, what did it say? 313. And when we looked at that under the scope, okay, let's how do I check varistors? Well, short from making a jig with a power supply and all that stuff, you know what I'm going to use, right? I think you guys know what I'm going to use. I'm going to use that because this allows me to check varistors if I needed to, which you guys already know. If you saw any previous videos, you know that that's what that does. We use an insulation meter to check. So I can go into We can check this out, pull up the specs, which I've done on this before on the last video, and we come to find out that this is rated at 530 something, 533, 537, somewhere in that range. So if we were to take this, okay, and put it under test under here, okay, we can do a test over here and see what it's going to read. We know it's 500, so we can basically, if we needed to, we can just go to the 500 volt scale and we can test that and see where it goes to. But we're higher, but I did an adjustment on it already, so that part's covered. I'm not going to go through it all, but I'll show you basically what I mean. We can hit that button right there and we see 533 volts, okay? We're grounded 0.3, okay? We're grounded. If it went to 250, so the maximum voltage that's going to come out of here is 250 volts, okay? So if I hit that, hopefully you guys can see, because I don't know that you can. So we'll hit 250 because the rating on that has to be higher than 250. We probably won't see it ground. We might get a portion of it, but not all of it. So you see here, we're putting in 250 volts. We've got 6.5 gigaohm. Okay. 6.5 gigaohm. So we didn't bring it down to a ground state. It has to be what it's rated for, which was the 533. I'll do this one again because I don't know if you guys got to see it or not. 534 volts, 0.3. Now it's grounded. And that's what a varistor does. It grounds or shorts to ground when it reaches whatever the spec was on that inrush of current or voltage. So that being said, let's test this one here. And let's see where this one's rated at. And I didn't look this one up. So we'll start off low. We'll start off at 50 and see if it breaks down. It's probably going to be higher, obviously. Yeah, it's not going down. Let's try 100. Yeah, still not breaking down. Let's go to the 250 scale. So it breaks down at 225, 226 volts. So that's why I like an insulation meter, because I can get a specific test done on a varistor and tell if it's any good or not. And it shows me where it breaks down at, so I can tell if that's good or not. Because we know from before, if we tested that, we don't get a continuity. So if we go back, we try to do continuity, okay? Let's go to continuity here. Where are we? All right, so continuity, right? So if I go and touch this other side, we get nothing. Okay, we get nothing. Nothing. Those are good resistor. Now, let's go to these supposed capacitors, right? Let's go to the supposed capacitors. Because Google told us that these are capacitors, not varistors. So let's do an experiment. Let's test this and see what happens. All right, we're going to hit it with 50 volts first, see what happens. Not grounding out. Let's go to 100 volts. Still not grounding out. Let's go to 250. It should now. Still not. Okay. Let's go to the 500 volts go, which I adjusted internally, and it actually goes to 600, I believe. Anyways, let's try it now. Still nothing. All right. Let's go to the 1000 volt. Let's see what that is. And this will only go up to 1000. Still in the giga ohms. Okay. So it's doing its job. It's not a varistor, but it's making sure that that voltage isn't going through. Okay. Because it is a safety capacitor. Okay. But it's just a different kind, guys. It's a different kind. So you need to know how to check them. That would be the wrong thing to check it with, obviously. You were able to see before that we were able to take these particular capacitors and actually test them via regular capacitance, and they show a reading, so you can test them that way. These work differently. These actually short to ground when they reach the threshold. So I just emphasizing to be cautious when dealing with capacitors or any other component, but capacitors too. If you're dealing with anything in the high voltage electrical area, it is dangerous. I would only do it if you know what you're doing. If you're not comfortable messing with high voltage, don't do it. Don't go in there not knowing what to do. You need to have some understanding of that circuit before you try to get in there and try to do anything. And like I always point out, and I'll show you guys once again, if you look at most boards, okay, if you're looking at most boards, there's a split, and this board really shows that really good, as you can tell. Your high voltage, which is normally tagged as hot or primary, okay, you have a primary and secondary. You'll always see an outline, as you can see here, you see the dashed white line that goes around, and it shows you everything from that white line in is high voltage or hot. And everything beyond that would be the secondary, okay, which is a lower voltage that can still hurt you, but it's not as hot as this side or not as high a voltage as this side. So, and usually how you can identify that as well is by looking for your optocouplers. That is what they use to have that isolation between your high voltage and your lower voltage. They don't want any of this getting into here. So it uses isolators, the optos, for that. Okay. And they come in different configurations and whatnot. But that's usually used, and it's regulated via sampling of the regulator that's on the secondary side. It senses the voltage, and this tells the main controller chip how much voltage to produce or give. It reads it. That's a crude understanding, but it's kind of how it works. So that's how it judges or knows if everything's fine. If there's something wrong on this side, this will shut down the circuit. And in the same respect, if something goes wrong on this side and it doesn't read correctly, it'll shut it down as well too. So it's kind of a protection circuit that's in there. That's how that would work. Anywho, I need a drink. I don't know how long it's been running, but we're going to get to the final stages here. So now, this is why I like this. As cheap as it is, it does many functions, right? You guys got to see. It'll read a resistor. It'll read a diode. It'll do all those different components. It's multiverse, right? So that's awesome. We want something that can do so many different things. And that's why I recommend having this regardless of whether you get a peak or not. You should have one of these because you can do different things. So now, if I wanted to test an inductor, I could put this in here and we should be able to test an inductor as well. Okay. There you go, inductor. It says this is a 0.02 mH, microhenry. Okay. So if we look at this, we have 220. Okay. It says 220 micro. Doesn't have an M, but that's what this came up. Let's try it again. My batteries, I think, might be getting low on that. I'm not sure. It even tells you the resistance here, 0.11. So, see if you guys can see that. Okay. So we're able to check inductors as well. Now, not every multimeter checks inductance. Okay. This won't check inductance. Okay. It won't do it. Doesn't have an inductor. This one also, I don't believe it has an inductor on it either. So you're not going to check it on that. We can go back to this one. Okay. And see what it tells us this is. Okay. Just to see. I can never get these things always in the wrong place. And doesn't look like we're able to check inductance on this either because it's just reading it like a piece of wire. Okay. So it ain't going to work either. I'm just trying to show your different things. Regular multimeter is not going to show anything either. So what do you need? Well, you need this for sure, right? But if you didn't have this, you can find multimeters that will read inductance, like this one right here, which I'm about to show you, is a meter that will read inductance because it's got a scale for it. As long as I put the wires or the probes in the right place. So this will do millihenries. Okay, it'll do the microhenries and regular henries. So the other one said it was 0.2 or something like that. Let's see what this one says. 0.0223. Okay. So it vouches for that other tester. Okay. It vouches for the other tester. Now we could put it on Henry's. And that's going to drop it down even more. Should go to 2. Yeah. So there you go. You can find multimeters. They don't make them every day anymore. This particular brand here happens to be one that came with that and came with other functions as well, as you guys can see here. This has got the inductor test. It's got microvolts. It's got hertz. It's even got a logic tester, okay? And that's because I don't have my probe in the right place, okay? You got a logic tester, diode. So it's even got a dB scale. So this is a specific meter for a specific test. It's an older meter, but it's an awesome. I like it because one of the main things I like it, which what did I say about everybody has a preference? I liked it, yes, because I had all the availabilities of having these tests, but I like the blue screen. It's got a blue screen. Can't see it real good on there, but it's basically a blue screen. And it comes with a magnetic, lanyard, so you can work on it. It's good. It's a good electrician's meter, but it's also good for computer. I think it really more of a computer electronics type, you know what I'm saying, tester, because of the fact that you have all your normal multimeter selectables, plus it's got logic. Well, you're going to use logic on your dip switches and whatnot. Hertz still has that. So it's pretty cool that you have those functions on here. But we also have this one, which we know will do also inductor. So we can get in here and we can read that inductor and it'll tell us what it is. There you go, 22.7. So we have another means. You guys are going to be like, I need to buy more equipment. So, yeah, I mean, you got that out of the way. Sometimes you have to build your own thing. Now, I will say this. I don't know that this will do it. I'll try it. If I wanted to check a crystal, will it check it on here? I don't know. Unknown part. Let's try with this one. Unknown part. Now, I believe this one may not do it, but I believe there was one that I had that could at one point. And I think this one had the ability possibly to do those, to do crystals, but I'm not really sure. So what I have, I've made up my own little board so I can test crystals. And it's kind of also a go, no go, but it also, you can put this on your oscilloscope. You can run power here. See, I think it was either 5 volts, 9 volts. Let me dial it into about 5 volts and see. It's been a while, so I can't remember exactly. I've been using this for ages. So you see we have a light. So it's already telling me that we're good. We're powering it on and it's running right now. So if I had my oscilloscope, I would tie into ground and then probe, and then I would get a reading on my oscilloscope. That's what I made that little tester for. so you can test crystals. So that might be a little project for another day. Go through that. All right. So we have a means to check that as well if I need to. Let's get to testing these components here. So this is where this is going to shine, because now we're able to test these unknowns. And also, just so you know, guys, that one tester will not it says it's an NPN silicon. All right, so we got our readings, and then here we can go through all the specs. It'll give you everything you need. And then when it's done, it'll go right back to the beginning. Okay. So you can figure out, what was that? What is that? I'm going to check these out too while we're here. Find out if it's a diode or, a rectifier, or is it a some sort of transistor. This is also an NPN silicon VJT. And you can go through the specs on this too. All right. And let's test this one and see what this is. Hopefully we can get something different besides NPNs. This is an N-channel MOSFET. Here we go, enhanced. There you go. And then you can go through and get details on the stuff. Now, this one too, what it does differently too, on this particular, these don't have it, I don't believe, but on this you actually have an interface. Okay, you have an interface right here via USB, and you can plug this into your PC, and you can have the same information you're getting here on your screen, and you can have a bar graph that you can use, which this is pretty neat. And you can see when you pull up the data files for these things, most components, and you know how you can scroll down and you see these charts, and they have the bar graphs of, their max and minimum peaks, and with the values coming across and all that. This is what you can do with that. You can have your own bar graph, go through it, test it, and you can find out what's going on. So that makes it really nice too. That's why this is a professional grade versus that regular tester. Now I can tell you this too. This will not test regulators like your 1 volt, your low, that you find in your PCs, that you're doing laptops repair, or many other components. You find the little SOTs, or a little bit bigger, whichever, and you have little regulators, either 1 volt regulators, 2 volt regulators, 3 volt regulators, 5 volt regulators. Well, this doesn't test any of that. It can't. This will test regulators, and I'll show you that. I'm going to pull a regulator out of my stuff here. Let's see here. Can't remember which one which one I got my stuff in, so bear with me here. Mm, these are not my regulators. Where are my voltage regulators? Trying to find stuff, guys. Sorry. Thought I had them there. Where are they? Oh, yeah, that's right. I put them in here. I'm not sure. I think I put them in here, guys. Let's see here. Ducky diodes, NPNs. Here we go. Are these it? 78s. These might be it here. 78, 79s. There is a limitation on the regulators. I think these might be a little bit too big. We'll try it and see, but I think it may be a little bit too big. May not do it. We'll try it. Ain't gonna hurt nothing. But it will do regulators. I just don't have any smaller SOTs right here right now, so handy. We'll try this and see if it works. Yeah, there you go. You'll see. Okay, so regulator. It tells you the voltage. Tells you the dB out. And gives you your leads. So that is a voltage regulator tester too. Comes in very handy, especially working on laptops. You need to check those regulators, see if they're any good. You can do it on here. You don't have to just use a voltmeter and see if it's shorted. You can actually test it and make sure it's doing what it's supposed to do with that. Now we're going to try it on here just to prove to you that it won't read this at all. Oops. Just doesn't know. Just doesn't know. So why you have to have more than one test device. This is good for many things that you may not can get working on here. And then there's things that this won't read that this will. Same thing with this, or same thing with that. This will go up to, I think, 100-volt capacity as far as the Zener goes. I believe it'll read up to 100 volts Zener. Don't know that one will. So we kind of covered all of this. We didn't cover, but I think you guys have seen other guys out there that have these to test. So you can turn this on. Yeah, it's on. Okay. So now we can test this. We got pin number one on here. And then your optocoupler's got a dot on it. For those who can see good, can see. Yeah. So my dot's over here. So if I put this here, we should get a green light on our. Here you go, green. That means that is good. It won't focus, will it? Anyway, it's green. So it's got the pogo sticks. And why these are nice is because you can test this in circuit. I'll show you. Trying to see where my dot is. That one's not reading. So maybe that one is faulty. Thought there was another one on here. Yeah. Is there? That's a dual one. I don't know if it'll check a dual one or not. Yeah. I don't know why it didn't check that. It should. Kind of hard to believe that thing's bad. But it's definitely not reading. Normally they do read. So not sure why that one's not. Okay, well, anywho, that one is reading. So, and it may be that it won't in circuit. Who knows? But it is reading green. So, good little tool to have. So you don't have to fuss about how to check it if you didn't have this. You can check this while it's in a board, but you're going to have multiple things. You have to have a voltmeter, a power supply, and you bring all that together. And you can put a resistor in line 2, and you can check these. But that's a lot of work. Where now with that little tool, you don't need all that, and you can tell if it's go no go on it. So guys, I don't want to make this any longer than what it is. I think we had a good amount of things, kind of focusing on different tools, what you're going to be using to test things, how to test it. The main goal, once again, out of the whole, where's the gold? Well, the gold is you got to go mining for it, right? Nothing's free in life. You got to mine for it. It'll cost you your time and work, but you can get to the things that you want. You can get to the things you want, and that's the main thing. You can find this, pull the parts off of it. You can it won't take you long before you have a good supply of parts. And a lot of these parts, believe it or not, are used repeatedly in a lot of other circuits and a lot of other devices. So it's not like you're going to be pulling things out that you're probably never going to use. You will. And like I was saying before, fuses. You got fuses you can use anywhere, right? Capacitors, safety capacitors. You have your diodes to make up a bridge rectifier if you need to. You're going to get different sizes, okay? You're going to get plenty of MOSFETs and diodes, okay? You're going to get ceramic resistors, okay, that you'll have. And those are usually spec to a certain resistance and wattage. Transformers, capacitors, heat sinks, you name it, it's on here. More of the optocouplers. What else do we have in here? I mean, connectors, you know. So you get the idea is that, and ICs, you're going to find ICs that may or may not be good, but they're there. So there's a wealth of parts that you can get from all that stuff. So I was just pointing that out, kind of cleaning up here a little bit, this mess here real quick. And what else can I show you guys? Let me get the cam and I'll show you around a little bit. If I can. I don't know what that's about, but anywho, I guess you guys are still in focus. So you guys see the my arrangement here. It's a mess, but just a little shop tour so you can check out equipment and whatnot, because most of the stuff's hidden in the back anyways, so you're not going to see everything. Like back here in the cubby hole, let me move this out of the way. See the rest of the gear back there. Got my spools of solder and whatnot there. I want to show you this here. You guys know what that is right there? That is an updraft ventilator, kind of like what you use for soldering purposes. You want the smoke. Well, this is basically the same thing, but it's flat, all stainless steel. It's got a carbon filter in it and it's got dual filtering, just like you do with the soldering filtration. When I first started this is what I had. This is what I used, and it kind of worked backwards, but it worked good. You can lay your stuff here, and it would vent. You got the side here. You got your power switch, and then your knob to regulate the fan. You put this on high. I don't know if you can hear it. And then this here just sucks air throughout this whole area. So anything you put here of any kind of fumes, they go in here into the unit, up through here, and it vacates on the top. And that's, you know, going through all the filters. So this old school stuff. I pulled it out the other day because I was like, what am I going to do with this thing? It's taking up room. Probably going to try to remodify it and do something else with it. I want to show you some more boards. You guys don't think I'm kidding. Look at the boards that I have laying everywhere just for parts. Okay. And there's more. There's underneath my bench. There's a whole bunch of different just supplies of things. You know what I'm saying? More on the side there too. So you can never have enough boards and junk. And there's some more of the madness. You guys can see just a bunch of equipment and supplies. More stuff up here, speakers. More of my good new supplies up there, you know, if I need it. You guys remember this thing? My other microscope over here. Look through there, you know, if we need to. Old tube set for gaming stuff. A little power supply kicking back here. Just more stuff. More meters up there. More equipment over here, over there, everywhere. I got stuff in the drawers. I got stuff in here. I got some food supply hidden back there. Some backup food. So yeah, I mean, it is what it is. I don't know how far this thing will work. Can we go outside? You guys want a tour outside? I don't know if it'll keep working, but yeah. But this is my little home paradise. You guys can see. All I need. Does what I need, guys. So you got the 2 cent what do you call it, little tour of everything, and there's of course more stuff up there as well, bagged up, more equipment. So anywho, let me see if I can get this situated without knocking it down. It's always fun. See if I can get that going again. Oh, it's frozen. I must have done something to it. Oh man, come on. There we go. Sorry about that, guys. So anyways, I'm glad you guys could join. I'm glad I could share what I can share with you guys. I hope to bring more to the table as time goes on. Wednesdays, this what we want to do. I want to do a live so I can actually talk, you know, to you guys. You guys can ask questions or whatever, but I want to see if I can get someone to help me, you know, kind of monitor if I'm doing things, because I don't want to be sitting there going, looking at the screen and then not paying attention to what I'm doing. So, but till I get used to it. But anyways, guys, I hope you enjoyed this. This was kind of like a smorgasbord of things, but the main goal was sourcing parts. The best way to do it, get out there, look for it. It's out there, guys. The gold is out there. Just got to dig for it. Got to do a little work. You get your parts for free. You can repair your equipment. You can play with the parts and build tools and whatnot. I mean, it's the availability is there to do it, and we got to kind of talk a little bit about the hand tools that we have, meters and whatnot, to do what we got to do so we can check those parts so we know that they're good, they work. We get knowledge, we get to learn what they are, what they do, what they look like, all that good stuff. We even get to pop some things every now and again and let some smoke out. That's always fun too. So as long as you're safe in doing it, remember that. Just be safe. With that being said, hope everyone's doing well, and we will catch you at the next one. Bye for now.